Okay, we're going to discuss mutually exclusive events. So first we have to say what mutually exclusive means. So mutually exclusive means that if one of them happens, then the other does not happen. So let's say you have two events A and B. If A happens, then B cannot happen. If B happens, then A cannot happen. It's actually also possible for either of them to happen. But if one happens, it excludes the other one. The other one is not actually possible anymore. So that's mutually exclusive. Now, there's a formula. So, if two events are mutually exclusive, then we could say that the probability of A happening or B happening is just the probability of the first plus the probability of the second. And that's only true if it's mutually exclusive. So if it's mutually exclusive, then that's it. If it's not mutually exclusive, if not, to be seen. We'll find out. Okay, so let's have an example here. It's a long one. I'm not sure if it's necessarily worth writing down, but you can if you want. Zachary's on the baseball team. Starting positions are randomly allocated, like any good sports team. The probability of Zach being selected as starting catcher is 20%, and the probability of him being selected as starting shortstop is 50%. What is the probability that Zach will be starting catcher or shortstop? Oops, I'm kind of, well, the thing over there. Okay, you can pause it now and write the whole thing. So, what we have to ask ourselves is, are these, do we have a situation where we have two events that are mutually exclusive? So first of all, what are the two events? So the two events are A, that he is the starting catcher, and B is going to be that he is the starting shortstop. So if one happens, does it exclude the other one? So if the starting catcher, then he cannot be starting shortstop. If he's the starting shortstop, he cannot be the starting catcher. So these are mutually exclusive events. Now we know from the question that the probability of him being the starting catcher was 20%. And the probability of him being the starting shortstop was 50%. And since they're mutually exclusive, what we could say is mutually exclusive. So therefore, the probability of being catcher or shortstop is just the probability of catcher plus the probability of being the shortstop, which is 0.2 plus 0.5, which is 70%. Okay. So let's have example 2 here. What's the probability of pulling a queen or a heart from a full deck of cards? So the two events here are, we have the probability of a queen, and then we want, we have the two events are, we're going to have a queen and we're going to have the heart. And are they mutually exclusive? They're not. It's possible to have a queen that is a heart, the queen of hearts. So these are not mutually exclusive. So since they're not mutually exclusive, then we know that the probability of A or B is not in fact equal to the probability of A plus the probability of B. And if you remember our Venn diagrams, if things are not mutually exclusive, so if we have two things over here and we add them up, probability of A is these two, probability of B is these two. We've double counted this one. So how do we fix it? It's going to be we'll have to come back to that question in a second. It's going to be that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So in the context of this, the probability of, let's do it over here. So the probability of getting a queen from a deck of cards is going to be 4 out of 52. And the probability of getting a heart from a deck of cards is 13 out of 52. And the probability of getting a heart and a queen, there's only one of those. It's 1 out of 52. So what that tells us is that the probability of getting a queen or a heart is going to be the probability of getting the queen plus the probability of getting the heart minus the probability of getting the queen that's also a heart, which is going to be 4 out of 52 plus 13 out of 52 minus 1 out of 52, which is 17 minus 1, which is 16 over 52, which is 8 over 26, which is 4 out of 13. And there you go. Now, there was other ways of doing this. What you could have done, of course, going back to our free body diagram, not free body, our Venn diagram. We have the queen. I have physics on the mind. We have queen. We have the queen and the hearts. The probability of a queen or a heart is also the probability of a queen plus the probability of getting something that's not a queen but a heart. Because the queen is going to be these two guys, not queen and heart is just that. In the context of this question over here, there's 4 out of 52 ways of getting the queen. And the number of hearts that are not queens, there's 13 hearts normally, but we need to not be a queen. That's going to be 12 out of 52, which would just be 16 out of 52, which is the answer we had before. Which of course turns into 4 over 13. The overall point is, if it's mutually exclusive, then you could just add them up. If it's not mutually exclusive, like our queen and our heart, then we have to play some, we have to be careful.